Good morning, everyone. Yeah. So I hope you people are doing great. Today, exactly at 7 o'clock, I have logged in. So a lot of people has to come. Let's wait. Let's wait for that. Sir, you have not uploaded day 6 notes. You know, I have uploaded. I think so. Did I? Okay, I think I have uploaded, right? No. Uh, okay. Maybe I have forgot that. So don't worry about that. I'll upload that today. So I'll upload the last class PDF today. Sir, is this notes is enough to attempt MSQ, sir? Yes, that is enough. Don't need to go further too much. So in the previous session, we have been discussed about the specific energy topic, and then we discussed about the applications of the specific energy. So let's go back to the previous session. Once again, a quick review. So please have a look. Yeah. So what is the specific energy? Specific energy is the total energy per unit weight by taking the channel bottom as a datum. So if we take the channel bottom as a datum, the basic assumption that we are going to make sure here is the channel bed as horizontal and frictionless. Now, whenever we make sure that what is the specific energy? Y plus V square by 2G. And from this, the main applications of specific energy are to define the critical flow. That's what we have been discussed in the last chapter. And then to analyze the flow over the transitions. So in the case of the critical flow, we know that the critical flow occurs when specific energy is going to be minimum, and when specific energy is going to be minimum, and then discharge per unit width is going to be maximum. So we have been discussed about that by means of a two curves known as a specific energy curve. So what happens when the relation between the specific energy and channel bed? I have been discussed about that. This is one of the transition. Whenever there is a rise in the channel bed, then specific energy is going to be decreases, and then as a specific energy is a function of the depth, so obviously the depth of the flow is also going to be gets varies. So in order to study when a specific energy varies, how the depth is going to be varies, we are going to use a specific energy curve. And in this specific energy curve, I have explained how this curve came by means of the E is equals to Y potential energy curve, and E is equals to Q square by 2G A square kinetic energy line. So by combining these two, if you add both, then Y plus V square by 2G, then that curve is going to be the E curve, which looks like a cubic parabola. So the shape of the E curve is going to be cubic parabola, my dear. This is not a 2-degree parabola. This is a 3-degree parabola, cubic parabola. And then from there, we discussed about that critical flow occurs at a minimum specific energy, and for any specific energy other than a minimum, there exists a two depths known as alternate depths. Apart from that, we said that see, in the E curve, upper limb is going to be asymptotic to potential energy line and lower limb is going to be asymptotic to E axis. And where do we see the alternate depths? I have said that. Now the final conclusion is I have said that in the case of the E curve, in subcritical zone, the curve is going to be rising. The curve is rising means as a specific energy increases, depth of flow is also going to be increases. And in the case of the supercritical flow, it is exactly opposite, because a supercritical there is going to be falling. So finally, my dear students, you can understand that whether the curve is going to be rising or falling. And based upon whether it is rising or falling, you are going to define the flow behavior. And this curve is especially useful when the case of channel bottom transition. Channel bottom means whether the channel bed rises or channel bed falls. So specific energy curve is useful in the case of channel bottom transition. Now, in order to go for the channel width transition, in order to go for the channel width. See, here there is no change in the channel bottom. When there is no change in the channel bottom, specific energy remains same because at this E1 and here E2 both are same. When E1 and E2 both are same, then you cannot use the specific energy curve. So this is a width transition. Now I am going to show you whatever this plan view in the practical view. I am going to show this practical view also, so keep that in your mind. Now in this plan view, in the transition zone, when the width is going to be reduces, then you know that the water surface is not going to be constant. The water surface will change. And in order to analyze this, I am using the discharge curve from the equation. So from this equation, from the same specific energy for the rectangle, I have made this equation. And from that equation, I have drawn the discharge curve. And from the discharge curve, you can see the absolute, the critical point is going to be the critical flow occurs at a maximum discharge per unit width. And now this curve is exactly opposite to the specific energy curve. Yes, because in the case of the supercritical and in the case of the subcritical, now discharge curve is falling. So inversely proportional. When the curve is rising, directly proportional. When the curve is falling, inversely proportional between X and Y. So now let's see how to use these two curves elaboratively in the case of the transitions. So how many transitions I mentioned? One is channel bottom transition and other one is going to be channel width transition, which means one is going to be in plan view, what is a transition? The other one is going to be in the sectional view, longitudinal sectional view, what is the transition? So let's see how to analyze those transition. Let's see how to analyze those transitions. So by using this specific energy curve and discharge curve, as I already mentioned you, the E curve and the Q curve are useful for flow analysis in channel transitions. So one more thing I want to make sure for the ESC students especially. So my dear ESC students, so there is a possibility already for the schedule has been came for the ESC preliminary examinations. It will be around in July 17th, 2021 for the ESC 2021. Actually, the schedule is going to be like so the normal dates. It would be like the first week of the January, first week of 2021 means January 2021 first week. It should be there normally, but due to the COVID scenarios, all the government examinations so far has been postponed, and they have given the 1 year along schedule. In that schedule, it was mentioned engineering service examinations on July 17th. On July 17th. So which means the examination of ESC prelims has been postponed to 7 months. And for the further confirmation, we have to wait for 1 to 2 months, because in 2 months, the ESC prelims notification is also going to be coming up. Just like whatever the IIT Bombay has released the GATE syllabus and all. So within 1 or 2 months, the ESC prelims notification also comes, because in order to apply for the examination, they have to release the notification, right? So the exact details and confirmation details will be known in 1 or 2 months. But as of now, from the UPSC calendar, it was given as the engineering service examinations, prelims examination is on July 17, 2021 for ESC 2021. And about GATE, already we know that in the GATE brochure, they have clearly mentioned, in the GATE brochure, it has been clearly mentioned the GATE examination dates will be further modified based upon the situation at that corresponding time. So as of now, they have given the dates in the February 1st and 2nd weeks, from February 5th to February 12th. And based upon the situations, based upon the conditions at the end of this year or the first month of next year, means January. So they are going to be postponed the examinations, or they may conduct at the same date. So if all the things are going to be goes well, then the examination will be in February only, else it may get postponed. But make sure that we think the things will be goes smooth and fine by the end of this year. And we never know when the vaccine is going to be coming out. And a lot of speculations are going around over here that Russia is going to be the first one who made the vaccine. but I'm going to clear that. Means already the WHO also cleared that it's not even in the final trials also. It was only first trials. So for any vaccine to be get to the market, it will take a minimum of 6 to 8 months. 6 to 8 months after that trials, it will take 6 to 8 months, because so for every vaccine to be released, it requires 3 stages of experiments. Right now, in the entire world, the two companies that are in competition is one is UK-based AstraZeneca from the Oxford University, UK-based, so England-based AstraZeneca, one company, and US-based Moderna. So these were the two companies which are on fight to get the vaccine towards the COVID, but they were also in stage 3. And in India, as we have been started, you know that around in June itself, so we got some speculations that vaccine will be coming on August 15th. At August 15th, when? Because there is no vaccine, because they are doing the stage 1 and stage 2 trials simultaneously. It will take more time. So hope so by September ending, we may get some results from AstraZeneca and Moderna. And again, it will take 3 to 4 months to get that vaccine to the end there. So possibly 2020 will be like this only. So we cannot do much about that, and we have to accept the fate. So this year possibly there might not be any offline classes, and everything is going to be goes on online only. At least we have to sing a song, go Corona go, go Corona go. Otherwise we cannot get rid of this Corona. So I hope you remember when the Corona has started, a lot of people were saying come to the class, means come to the road, and they sang a songs like go Corona go. So I think the Babas who used to give a lot of boons, they might help us to get rid of Corona, especially Dera Baba, Asaram Bapu, and Ramdev Baba right now. They should come out and they have to show off their powers to get some vaccines for us. Okay, fine. So now let's come to the discussion. So what I want to show here is, you see, everyone, have a look over here. Whatever the channel over here, you can observe what is this channel. The channel cross section is going to be here. This channel cross section is going to be rectangle. Yes or no? So whatever this is a rectangle. Now this rectangular channel is going to be transition. Transition means a change. Yes. So this rectangular channel is going to be transition. See, from here onwards, it is going to be transition, and then from here onwards, it is going to be trapezoidal. Yes or no? So I am showing you a canal section. So where there is a change in the section from a rectangle to the trapezoidal. So here the transition is happening from rectangle to triangle. Okay. Now, so rectangle to trapezoidal. So this is trapezoidal. Now, if you observe in the plan view, if you see, the width of the channel has been reduced smoothly. Yes or no? The width of the channel has been reduced smoothly like this. Yes or no? So initially the width of flow is going to be B1, and then the width of the flow is going to be B2. So can I say in the plan view, it looks like in plan view, the width has been reduced from B1 to B2. So whatever the width over here is going to be B1, and whatever the width here is going to be B2. Now, when I allow the flow into this canal, I have to make sure whether the water surface level is going to be constant, or whether it is going to be false, or whether it is going to be rises. So at this section, the sectional cross section is going to be rectangle. Here it is going to be trapezoidal. So during channel transition, the rectangular section is going to be changes to trapezoidal section, results in the width transition, So I can say this is going to be width reduction case. Yes or no? So this is one of the practical example where or whenever a channel cross section shapes changes from one shape to other shape, there might be changes in the bed width. That results in the width reduction transition. That results in the width reduction transition. So what is the use of this transition exactly? See, whenever you are going to change the path of the flow, whenever you are going to change the path of the flow, then definitely you require the transition. For example, look, you know the topography is not going to be linear, right? So there may be meandering like this. There may be meandering. Meandering means a curves would be there. So some transition curves, or in simple words, I can say, I hope in transition means in transportation you came across horizontal curves, vertical curves, and a transition curves. Yes or no? Where do you observe the transition curves? The transition curve is going to be present between two horizontal curves or a vertical curve and horizontal curve. Yes or no? So wherever you are going to change the flow pattern, wherever you are going to change the flow pattern, there we are going to go for the transition. Okay. So now this is with the transition, and similarly. Yes. See, you can observe one more here. If you observe this point, yes, here. So whatever this is nothing but width B1, and here it is going to be width B2. Yes or no? So this is going to be width expansion case, my dear. This is width expansion case. And now you see here, this is a channel bed, right? And in this case, the width is going to be constant. Keep that in your mind. The width is going to be constant. This is a width B, and here also width B. But if I draw the longitudinal section, right? If I draw the longitudinal section, then the channel bed is going to be false like this. So the channel bed is going to be drop something like this. Yes or no? So here, this is a channel, and here this is a channel. The channel bed has been dropped like this. So when the channel bed transition, this is channel bed drop transition. So whenever you are going to allow the flow from upstream to downstream, generally you are going to allow the flow by means of channel bed drops. So why we will discuss that later. So channel bed drop. Okay. Now this is width expansion. This is width means a drop. And you can see this is the famous Panama Canal. This is the famous Panama Canal, where you can see this is a canal, right? And you can observe the width of this canal is going to be increasing from B1 to B2. This is B1, and here it is going to be B2. And this width is going to be ranges over 60 to 70 meters. The width of this Panama Canal is going to be around 60 to 70 meters. Okay. So you can observe this Panama Canal is open channel flow, and where the transition is going to be takes place smoothly. Observe clearly, does the transition is happening suddenly or smoothly? Smoothly. They are not increasing suddenly from B1 to B2. They are increasing over a period of time from B1 to B2. So again, this is going to be, what is this? With the expansion. When you see the flow coming from here, then there is going to be width expansion. If you see the flow going from here, this is going to be the width transition. Okay. So now there is the Panama Canal, and likewise you can observe over here also, and you see. So here this is going to be the width of B1, and here this is the width of B2, and again here is there is a width of B3. So there you can observe the width is going to be reduced, the width is going to be reduced, and then width is going to be expanded. Yes or no? So here there is a width reduction and a width expansion, my dear. Width reduction and there is a width expansion. And you can see here the shape of the rectangle means channel is going to be rectangle. And then similarly, there is a parabolic. This is a parabola. And then there is a trapezoidal. So the widths are going to be changes from B1 to B2. So rectangle, this is going to be the parabola and this is going to be the trapezoidal. So wherever the channel sections are going to be changes from one shape to other shape, or whenever you want to lower the bed level, there we are going to apply the channel transition conditions. Okay. And apart from this, yeah, the same figure. So what I'm showing you here, the similar type of figure. So we have different names in the irrigation. In irrigation, we call this one as a canal falls. We call this one as a canal falls or chute spillways. Some other names would be there, and that we'll see later. And after all these things also you are saying the same thing. Sir, why we reduce this section? Wait for that, you will get to know. We reduce the section, we reduce the sectional width so as to control the flow rate. We reduce the sectional width so as to control the flow rate. See, if the width is going to be too large, then you cannot control the flow rate. Yes, that is the reason why we provide a sluice gates, my dear. For a dam, I'm asking you one question. For a dam, is there any single gate or multiple gates? If you take a dam, so along the length of the dam, you can see some gates, right? Sluice gates or control gates. Are you going to provide a single gate or a small n number of gates, small gates? Because when you provide a small gates, the width of the opening is less. When the width of the opening is going to be less, then you can control the rate of flow. Suppose if a dam has a single gate over the entire length, and if you lift the dam gates, then what happens? Then the entire flow comes to the downstream bed will collapse. So that's the reason why, in order to control the flow, we go for the channel width reduction. And coming to channel bed drop and channel bed rise, that depends upon the topography, my dear. See, when the flow is happening from the high level to low level, then you have to lower down the bed. See, here there is a width reduction and there is a channel bed drop. You can observe there is nothing but a double transition here. This is a double transition. Here this is a double transition because B1 and this is going to be B2, and the channel bed is also going to be drop or not. So if I draw the channel section, this is going to be the channel bed drop. So bed drop and width expansion. Width expansion and a bed dropper. So this is going to be the double transition, my dear. So now let's see how we are going to do analysis for this by using the specific energy and discharge curves. I'll be uploading D6 PDF today. So in the example, why this skillful specifically provided a parabola curve. See, why they provide especially parabola curve over here is for occurring the smooth transition. In order to make sure the smooth transition, they provide the parabola curve. Okay, fine. Now, let's come to the analysis. So, channel transitions. So now, so in the case of the channel transitions, we have a channel width transition and a channel bottom transition. And keep one thing in your mind, my dear. See, we are going to discuss one transition at a time. We are going to discuss only one transition at a time. we don't discuss both the transitions at the same time because theoretically it is not possible to predict the flow behavior. Theoretically, it is not possible to predict the flow behavior for double transitions. Then what to do, sir? We go for numerically or experimentally analysis. So for the gate point of view also, what I'm going to do analysis is going to be a single transitions, and then we apply the numerical analysis for the double transitions. So keep that in your mind. When I discuss about one transition, means if I say the channel bottom is going to be rises or drops, we are going to keep the width as a constant, which means when we discuss channel bottom transition, there is no change in the channel width, means no transition in the width. Similarly, whenever there is a channel width transition, we assume that channel bottom remain horizontal, which means when the channel bottom remain horizontal, then there is no channel bottom transition, right? So let's see. Number one, and keep that in your mind, these channel transitions are going to be applicable for rectangular sections only. This is applicable for rectangular sections only. So because Dr. K. Subramanya, he has provided the analysis for rectangular channels only. You take any textbook, they have given only for the rectangular channels. So that's the reason why we prefer only rectangular channels. And now, in this, number one, channel bottom rise or hump. So channel bottom rise or hump. So first one is channel bottom rise or hump. Okay. Now, in order to go for the channel transitions, we need to have some assumptions, right? So the first assumption over here is assume the channel width remains constant. Assume the channel width remains constant. So I'm discussing about channel bottom rise or hump, and assume the channel width remains constant. So that we are going to discuss about only one curve, yes or no? Which means in the plan view, I have to take the channel width remain same. When the channel width is going to be remain same, B, and here it is also going to be B. Now you tell me, when the channel width is going to be remain same, what is the discharge per unit width? Small q is equals to capital Q by B. Yes or no? When width is going to be same, then discharge per unit width is also going to be same. Yes or no? And when the discharge per unit width is going to be same, then there is no need of using the discharge curve. So what we are going to do here is, we are going to assume the channel bottom remain, the channel width remain same. Assume channel width remain same throughout transition. Channel width is going to be remain same throughout the transition. So throughout the transition, we are going to make sure the channel width is going to be constant. And now, if I draw the sectional view, so what I'm showing you here is a channel bottom rise, right? So now, keep that in your mind. You have to rise it with a smooth transition. So this is a channel bit rise. Let me draw these things. So remain same throughout the channel. So let me draw these things over here. So because I want the longitudinal section, and in the case of the longitudinal section, you see the channel bottom is going to be rises. The channel bottom is going to be rises. So let's take the channel bottom is going to be rises by an amount of delta Z. By an amount of delta Z. And keep that in your mind. The channel bottom, see point number one, assume channel width remains same throughout the transition. So if I say that whatever the width over here before the transition and after the transition, the width is going to be same. This is going to be B1 and here it is going to be B2, both are same. So the width before the transition and after the transition, the width is going to be remain same. And second point is we need to assume the channel bed should be horizontal and frictionless before and after transition. Before and after transition. So before and after transition, I am going to make sure whatever the channel bed is going to be horizontal and it is going to be frictionless. Whenever I made a frictionless, then my dear, then you know that if I make sure frictionless, then the total energy line is going to be horizontal. So now I can represent whatever this line, this is known as total energy line. Why I have drawn the total energy line as a dotted line? Because it's an imaginary line. We cannot see this line, right? And why I have drawn this one as a horizontal? Because I assume the channel bed is going to be frictionless. So no losses. We are going to neglect the losses. So whatever the losses we are going to see, we are going to neglect the losses because of the smooth transition. Because of the smooth transition. And if I do it sudden transition, then definitely there are going to be losses known as eddy losses. So as I am doing a smooth transition, the frictional losses are very less. So I assume it as a frictionless. So this is the first and foremost point that we need to know while before going for that transitions. Now I am allowing a flow. Let's take the depth of flow initially. The depth of flow is going to be y1. Okay. And it is going to be same up to this point. It is going to be same like this. Yes or no? Now you see there is a transition, and in this zone of the transition, what is going to be happen? So in this zone, what is going to be happen? That's what we require now. So for that, let me take. So which curve is going to be useful for the analysis of a channel bottom transition? Now you tell me. I have made sure. So as a channel width remain same throughout the transition, which curve is going to be suitable? Specific energy curve or discharge curve? Discharge curve or specific energy curve? So specific energy curve, or I can say, if you observe over here, yes, now you please have a look. Whatever the specific energy before that transition, this is known as E1, and whatever the specific energy after that transition, this is known as E2. Okay, so now from this, can I write E1 is equals to E2 plus delta Z. So as a specific energy changes and the Q remain constant. Q remain constant because what is a small q? Capital Q by B. So as a specific energy changes and the Q remains constant, which curve is going to be which curve is going to be useful? So specific energy, or in simple words, E curve is used for analysis. So these are the points that we need to keep in mind. Similarly, when I go for the width transition, then I have to assume the channel bed remain horizontal. And I have to assume there the channel bed remain is going to be horizontal. Okay. So now, let's see. So now use the E curve please here. Let's draw the E curve. Okay. So you can observe over here, whatever the E axis E versus Y, and this is nothing but a potential energy line. Now, you observe, whatever the curve you are going to draw, this is nothing but the specific energy curve. So this curve is going to be the E curve, and we know it clearly. Now, in order to use the E curve, you know that this is the point where the specific energy is going to be minimum, and we call it as a critical specific energy. So I'll draw this further so that I have much more information regarding to this. So now let me draw in this fashion. Okay. So whatever this curve is going to be the E curve, don't think this is going to be the parallel to the potential energy line, and you know that why it is not going to be parallel to the potential energy line. So keep that in your mind. Now, whatever this is nothing but E minimum or EC, and corresponding depth is going to be YC. And you know, above the zone is going to be subcritical. Above zone is going to be subcritical. So now let's observe. See, whatever the curve we need to analyze, we have the curve, and the entire data required for that is going to be ready with us. Now let's see the point by point. What is happening? So when the channel bed is going to be rises by a delta Z. Point number one, keep that in your mind. Point number one. So number one, when channel bed rises by delta Z. When channel bed is going to be rises by delta Z, what is happening to specific energy? When the channel bed is going to be rises by delta Z, specific energy is going to be decreases from E1 to E2. Yes or no? So this is the specific energy, right? The specific energy is going to be decreases from E1 to E2. Specific energy decreases from E1 to E2. Specific energy decreases from E1 to E2, which means so E1 is greater than E2 and E1 is equals to E2 plus delta Z. Yes or no? Now, let's see if the approaching flow is going to be subcritical. You know how come you say whether the flow is going to be subcritical or supercritical? How? How? You know that whenever the Froude number is going to be less than 1, then that is going to be subcritical. And if the Froude number is going to be greater than 1, that is going to be supercritical. So first of all, let's keep this point in the graph. Now, here is a graph, right? So in this graph, let me take whatever here, this is specific energy decreases, right? Whatever here, let me take this as E1. Let me take this one as a E1. Now, due to so due to when channel bed rises by delta Z, what is happening? Specific energy decreases from E1 to E2. Now this is going to be E2. Now this is going to be E2. Now my dear, this specific energy decreases from E1 to E2 by how much times? By delta Z only, right? What is the difference between E1 and E2? Delta Z. So which means whatever this difference between these two, can I say it as a delta Z, please? Can I say it as a delta Z? Yes or no? So now from the starting onwards to this point, whatever this is nothing but E1. And can I write E1 as E2 plus delta Z? So point number 1, when the channel bed rises by delta Z, specific energy E decreases from E1 to E2 by how much times? By delta Z. If you still have a doubt, you please go through this. So specific energy, what is the specific energy? E1 decreases to E2 by how much times? By delta Z. Now, if the approaching flow is going to be subcritical, approach flow is subcritical, then what is going to be happen? If the approaching flow is going to be subcritical, which means I'm making sure this approaching flow is going to be subcritical. So for the specific energy E1, what is the depth over here? Y1. For the specific energy E1, what is the depth over here? Y1. So now for this specific energy E1, now I'm going to show this in the subcritical zone. In the subcritical zone, whatever this depth represents Y1. So for a specific energy E1, if the flow is going to be subcritical, this will represent the Y1. And when the channel bed is going to be rises, you know, this subcritical is going to be rising graph or not. As it is a rising graph, when specific energy decreases, then water level also should fall from Y1 to Y2 because E and Y are directly proportional. Now you see, when the specific energy decreases from E1 to E2, now let's drop a point over here also. So now you see, this is nothing but Y2. So come on, my dear. From this point, can I say, when channel bed rises by delta Z, specific energy decreases from E1 to E2. When specific energy decreases from E1 to E2, then the water level will fall from Y1 to Y2. So if I draw, then it should be falling like this. Yes or no? It should be falling like this. Okay. So now that's not the end point. Okay, fine. With this, I can say one point as no change in upstream water level. Is there any change in the upstream water level? No. And from the transition, what is happening? Downstream water level falls from Y1 to Y2. Downstream water level is going to be falls from Y1 to Y2. So what is the meaning of this downstream water level falls from Y1 to Y2, sir? So let's imagine if there is no channel transition, my dear. If there is no channel transition, means if there is no channel bed rise. When there is no channel bed rise, then the channel bottom is going to be horizontal, right? And when the channel bottom is horizontal, then E1 and E2 both are same. So when the channel bottom is horizontal, then E1 and E2 both are same. If E1 and E2 both are same, then Y1 and Y2 both are same or not? So the meaning of that one is, if there is no change in the channel bed, then the water surface remain same. But as the channel bed is going to be rises, specific energy decreases. And as the specific energy decreases, water level is going to be falls from Y1 to Y2. Okay. Sir, fine, you're saying this one. Now, what if I raise the channel bit further, sir? Listen to my words first, then you can ask any questions. Sir, why did you assume the channel bed as horizontal in this case? Because I'm going to take show that it is going to be horizontal and frictionless. Okay. Now, point number 2. What if I raise the channel bed further? So now I want to raise the channel bed further. You see, I'm going to raise the channel bed further. If I raise the channel bed further, my dear, now what is happening? Please tell me. If I raise the channel bed further, what is happening? On the downstream side, the specific energy is going to be decreases or not? Think and say clearly. If I raise the channel bed further, now what is happening? I am rising, this is a channel bed, delta Z. This is going to be more than delta Z1. So I am rising the channel bed further. If I rise the channel bed further, then what is happening to E2? No change in E1. If delta Z is going to be rises further, if the delta Z value is going to be more and more, the specific energy decreases and becomes E minimum. Then decreases and decreases. You see, as delta Z is going to be increases, E2 value will decrease and decrease and decrease. At some point, it is going to be E minimum or EC. And let's say I am going to rise this channel bed by delta ZC. I am going to rise this channel by delta ZC. Then if I rise the channel by delta ZC, now the specific energy will decreases from here to here. Then whatever this is nothing but delta ZC. Whatever this is nothing but the delta ZC, my dear. So okay, I can write this is delta Z. Now you can observe. So from here to here, this is going to be, this is delta ZC. So if the channel bed is going to be rises by delta ZC, then this is going to be ECR. So now what is happening? Now what is happening? So if the channel bed is going to be rises further, if the channel bed is going to be rises further by delta Z is equals to delta ZC, then if delta Z is equals to delta ZC, then E2 will become ECR. When E2 becomes E minimum, what is the flow? Whenever the specific energy becomes minimum, then the flow is going to be critical flow, SR. When E2 becomes E minimum or EC, then Y2 will become YC, SR. Because see, this is E1 falls to E2, and now it is going to be falls to EC. So as a channel bed rises further and further, specific energy decreases and becomes EC, results in the critical flow. And then Y2 becomes YC. So now point number 2. Point number 2. When or if channel bed rises further as delta Z is equals to delta ZC, then specific energy becomes minimum. when specific energy becomes a minimum, then E2 is equals to E minimum is equals to EC. Then what is the relation between the specific energies, my dear? What is the relation over here? This is nothing but E1 is equals to E2 plus delta ZC. So now on the upstream side, the specific energy is going to be E1 only. But on the downstream side, now E2 becomes EC and delta Z becomes delta ZC. So this will result in what type of flow? Results in critical flow, and downstream water level depth shifts as Y2 is equals to YC. Y2 is equals to downstream water level depth will shift as Y2 is equals to YC. Because what is this flow? This is going to be the critical flow. Now, my dear, I hope you understood what is happening, because what I am discussing is nothing but subcritical flow, right? See, I am not saying here as a water level depth falls or rises. I am directly saying as a shift. So if you have any doubt, you please understand these values. So if you are going to raise the channel bed by delta ZC, then E2 become E minimum or EC. So what is EC? EC is nothing but the E minimum. Then the water level depth is going to be false by YC. So in practically, if I draw this one, practically the subcritical flow means larger depth, right? Practically what is happening over here is now you see, so water level depth falls and reaches whenever delta Z becomes delta ZC, then whatever the water level depth is there, right? This is going to be YC. So initially Y1, and now water level depth falls and reaches the YC. Okay. Now, so keep that in your mind. Okay. I hope you understood the first point number 1 and point number 2. Any doubt with this? If you have any doubt, you please ask me now itself, because I am going to discuss a new point here onwards. In simple words, what is happening here? Water level, downstream water level is going to be falling from Y1 to Y2 and Y2 to YC. Somebody is asking, sir, you have explained this point in conclusions also. What is the new thing here? Now you are going to see, my dear. The new thing is, I did not say there is a critical flow over there, did I? But now you got to know, whenever you raise the channel bed by delta ZC, then the specific energy is going to be minimum. I did not say that point over there. We still first point. What is the first point? When channel bed is going to be rises by delta Z, specific energy decreases from E1 to E2. Yes. When specific energy is going to be decreased from E1 to E2, then what is happening? No change in the upstream water level. Upstream water level depth means Y1. What is the upstream water level depth? This is going to be Y1. No change in the Y1. But what is happening on the downstream? Downstream is the flowing. The Y2 is going to be decreases than the Y1. You see, you observe. And some of the people are asking, "Arey sir, you are raising the channel bed, na delta Z." And okay, you are saying that, yeah, some people doubt, I understood. Sir, you are raising the channel bed by delta Z, right? So initially the depth is going to be flow as a Y1, and it is showing that the rise is going to be delta Z. Now, if I make sure like this also, then this is going to be Y2. And here also Y2 is going to be less than Y1, sir. Y2 is going to be less than the Y1, right? So can I say the water level is going to be constant? But why you are saying the water level is going to be false? Keep that in your mind, my dear. This delta Z is going to be very small in amount. This delta Z is going to be very small in amount. So don't think that y2 plus delta z is equals to y1. Here it shows y1 is greater than y2. Okay. But it doesn't mean that y1 is equals to y2 plus delta z. So water level is not going to be constant that much easily. Whenever there is a transition, water level will never constant. Water level will falls or it is going to be rises. As a y2 is going to be lesser value, then the water level is supposed to be fall. Yeah. Okay. So now the thing is, what if I raise the channel bed beyond delta ZC? I'm going to raise the channel bed beyond delta ZC. See, understand it clearly. What I'm showing you is in a different variations, right? If I would have raised the channel bed now, this is a delta Z which is greater than delta ZC. What if I raise the channel bed beyond delta ZC? Now, if I would have raised the channel bed beyond delta ZC, so look, if I raise the channel bed beyond delta ZC, what is going to be happen to the EC? What is going to be happen to the E2 now? This E2, this E2. So, my dear, now this E2 is going to be less than EC. Is it possible? What is the meaning of E2 is going to be less than EC? You see, you can observe in these figures. First of all, E1, then E2 plus delta Z. Then if I raise delta ZC, then E becomes EC. Then E becomes EC. If you raise more than delta ZC, then what is happening to E2? Then what is happening to E2? E2 is going to be less than EC. What is the physical meaning of E2 less than EC? EC itself is a minimum specific energy. EC itself is a minimum specific energy. Does the energy will become less than EC? No. Which means this is not going to be possible. Whenever I raise the channel bed more than delta ZC, whatever the figure represents, this is going to be the E2, which is the less than the magnitude of the minimum specific energy. So now it is not going to be possible. Why? Let's see the figure. Okay. Let's come over here. So if I raise the channel bed more than by delta Z, if this is delta Z more than delta ZC, then E2 will be somewhere over here. Yes or no? If this is the case, then E2 will be somewhere over here. Because I am showing you that delta Z is more than delta ZC, then E2 should be here. If E2 is going to be less than EC, if E2 is here, is there any flow? Is there any flow over here? No. Which is not going to be possible. So whenever the channel bed rises beyond delta ZC, then E2 should be less than EC. E2 should be less than EC, which is not going to be possible. So I can write a one point over here. Point number 3. If channel bed rises beyond delta ZC, let's say the delta Z is going to be greater than delta ZC, then specific energy should reduce, or specific energy should be less than E minimum, which means E2 should be less than E minimum. Is it possible? Is it possible? No, which is not possible. Which is not possible, and flow gets stopped. Such a type of condition is known as choked condition. Such a type of condition is known as choked condition. Flow gets choked. Flow gets choked means flow is going to be stopped. So if I raise the channel bed and the E should be less than E minimum. Generally, whatever the mechanism I'm going through here, actually what is happening? You raise the bed, specific energy is decreasing. And if that is the case, then E2 is going to be less than EC. But I am telling you it is not going to be possible. Array sir, okay, fine, you are saying it is not going to be possible. But in reality, I have to raise the channel beta more than delta ZC, sir. Then what is going to be happen, sir? Then what is going to be happening? Now think, see, already you are going to raise the delta ZC. And if you want to raise the delta ZC, if you want to raise the delta Z more than delta ZC, if you want to raise the delta Z, so whatever this is nothing but the delta Z more than delta ZC, and you want the flow to happen. If you want the flow to happen now, the only possibility is, so point number one, the possibility, the difference between the specific energy should be delta Z. Okay. Point number one, this is going to be E2, but this E2 is less than EC. This E2 is less than EC. Okay. This E2 is less than EC. It is not going to be possible. So I can remove this case. Now, point number two is by keeping the downstream E2 as EC only. Now, if I increase the channel bed as a delta Z, which is greater than delta ZC, what is going to be happen? This is the case 2, my dear. What I'm representing here is nothing but the case 2. Now, what I'm saying is, this is delta ZC. I'm going to take the downstream as constant. What is the meaning of downstream as constant? E2 is going to be EC. E2 is going to be EC. When E2 is equals to EC, see, you observe this figure first. Then, can I say this is nothing but delta Z greater than delta ZC? If I draw the figure like this, then what is going to be happen over here, please? This is now for this corresponding, now the upstream specific energy is going to be gets modified. The upstream specific energy is going to be gets modified as E1 dash. So what I want to say over here is, when you raise the channel bed beyond delta ZC, in order to occur the flow, either E2 should be less than EC. One possibility is E2 should be less than EC, or E1 is going to be increases to E1 dash. So as you know, the E2 cannot be less than EC, then the upstream specific energy should changes from E1 to E1 dash. The upstream specific energy should be changes from E1 to E1 dash. So the only one way the flow is going to be happen is, in order to occur the flow, when you raise the channel bed more than delta Z greater than delta ZC, in order to occur the flow, the upstream specific energy should increases from E1 to E1 dash. Now, when the upstream specific energy is going to be increases to E1 to E1 dash, E1 to E1 dash. Let's see that. I want to make sure. So now, if the upstream specific energy is going to be increases from E1 to E1 dash. Now, what is this? This is E1 dash. Then what is happening to total energy line? The total energy line is going to be shift from the total energy line. So I'll draw it down. Okay. Now, this is going to be E1 dash, and the total energy line is going to be shift from TEL to TEL dash. The total energy line is going to be shifted from TEL to TEL dash. So now, when the total energy line is going to be shifted from E, now you say, what is E1 over here? The E1 is going to be E1 dash. So this is nothing but a E1 dash. And now, what about the downstream specific energy here? The downstream specific energy E2 is equals to EC only. The downstream specific energy E2 is equals to EC. So now what I am saying you here, the conclusion here is, when you raise the channel bed beyond delta Z greater than delta ZC. In order to occur the flow, the upstream specific energy should increases from E1 to E1 dash. Upstream specific energy should increases from E1 to E1 dash, because once the flow is going to be critical, on the downstream side it remains critical only. So in order to occur the flow, then the upstream specific energy is going to be increases from E1 to E1 dash. So now what I am representing here is, in order to occur the flow, the only possibility when the flow is going to be occurs over here is when specific energy is going to be increased from E1 to E1 dash, the upstream specific energy increases from E1 to E1 dash. The upstream specific energy increases from E1 to E1 dash, and downstream specific energy remains critical. The downstream specific energy remains critical, which means E2 is equals to E minimum only, or E2 is equals to EC. So now E2 is equals to EC. Now please write down the relation between the E1 and E dash now. E1 and E dash. So generally E1 is nothing but E2 plus delta Z, yes or no? And whenever I raise the channel bed delta Z more than delta ZC, then what I am saying you here is E2 will behaves like a EC, and E1 behaves like E1 dash. So now you please observe all the three conditions. First, this is the condition, and next this is the condition, and next this is the condition. So whenever I go for the channel bed more than delta ZC, channel bed more than delta ZC, okay. Now if the E1 is going to be changes to E1 dash, now let's come to the graph again. If E1 is going to be changes to E1 dash, now for this E1 dash, if I drop a line, what is happening to value? Now this is going to be E1 dash. What about here? This is E1. Now what is happening? So everything is explained in this graph itself, right? Everything is explained in this graph itself. Okay. So what is happening? At first, specific energy is going to be decreased from E1 to E2, and then it decreases to EC. Now if you rise further, then this value cannot be less than this one. Then the specific energy cannot be less than EC, so that now E2 becomes EC, but E1 is going to be changes from E1 to E1 dash. Then what is happening to Y? What is happening to Y over here, please? So this is Y. What is happening to Y? Y is going to be increases from Y1 is going to be increases from Y1 to Y1 dash. And what about Y2? Y2 will remain YC. So now from this graph, I can say when the specific energy is going to be rises from E1 to E1 dash, E1 to E1 dash, now who is going to be changed? Upstream is going to be changed, or downstream is going to be changed? Upstream is going to be changed from Y1 to Y1 dash. So I can write from here, from E curve. If the approaching flow is going to be subcritical, you see, if the approaching flow is going to be subcritical, then upstream water level rises from Y1 to Y1 dash, and downstream water level remain same as downstream water level depth, downstream water level depth remain as y2 is equals to yc. y2 is equals to yc. So you please observe this point clearly. So why I am writing this one is, at first I said you what happens when E2 less than E minimum. The flow is not going to be possible. The flow is not going to be possible. So that is the reason why I said you when E2 is going to be less than E minimum. So the other way is, as E2 cannot be less than EC, the other way is going to be upstream specific energy is going to be modified from E1 to E1 dash. Sir, how come the upstream specific energy is going to be modified, sir? Because what happens, sir? The downstream becomes like a critical, sir. Now, whenever the downstream is going to be critical, sir, it will rises the water to the upstream. Means the disturbance will travel towards whom? Upstream. So when the water level is going to be rises from Y1 to Y1 dash, Y1 to Y1 dash, what is happening over here? So once the conditions are going to be choked up to this point here, no change in upstream. Here also no change in upstream. But whenever I raise delta Z more than delta ZC, the upstream water level is going to be rises from Y1 to Y1 dash. Now, you see, what is this difference, please? Can you tell me? Whatever this difference, I hope you can understand this. Let me go with some new color. Yeah. Whatever this difference and whatever this difference, both are same. Whatever this difference and whatever this difference, both are same, because you know here when delta ZC, this is EC, and delta Z greater than delta ZC, this is also going to be EC. So now how much total energy line is going to be shifted? How much total energy line is going to be shifted? Is nothing but whatever the excess rise that you are going to do. See, for example, let me take now from the figure here itself. This is delta ZC, right? You see, whatever this excess rise now that we have done, that much specific energy is going to be increases. Let me say the delta ZC is going to be 0.5. Let me say the delta ZC is going to be 0.5, and I am going to raise the delta Z as 0.7. You see, the critical depth is going to be 0.5. The critical depth is going to be, means the critical rise, delta ZC means critical rise is going to be 0.5, and I am rising a channel bed more than 0.5. How much? 0.7. So when I rise that delta Z more than 0.5, then what is happening? So the upstream specific energy will increases by how much? Exactly whatever this value is, nothing but 0.7 minus 0.5, which is going to be 0.2 R0. So the difference between E1 and E1 dash, the difference between E1 and E1 dash is nothing but the difference between delta Z and delta ZC. Whatever the excess bed rise that you are going to do here, that much total energy line is going to be shifted. That much total energy line is going to be shifted. Okay. So I hope you understood over here. So with this example, you can see if you raise a channel bed by more than 0.5, then that much specific energy is going to be increases. Now still it's not completed. Let me handle this with a figure, the practical view. So why can't we reduce depth to more than delta Z? Is this a question? How delta Z is greater than delta Z? Sorry, Baba, if you rise the delta Z more than delta Z, I am saying you, okay? If you raise the delta Z more than delta ZC. Now I want to ask you one question over here, please. I want to ask you one more question, one question over here. So in order to not to cause any changes in the upstream, see when the upstream water level is going to be changes, please tell me. When the upstream water level is changing, whenever the channel bed rises more than delta ZC, then only the upstream water level is going to be changes. Yes or no? So if you don't want any change in the upstream, then what is the maximum rise that you need to do? the maximum rise that you have to do without change in upstream is going to be delta ZC only, because I can write on a point over here, note point. The note point is the maximum rise of channel bed without change in upstream water level. Without change in upstream water level is, without change in the upstream water level is delta ZC. Why? Because up to delta Z is equals to delta ZC, no change in the upstream, only the downstream is going to be changes. So whenever the delta Z is going to be more than delta ZC, no, then the upstream water level starts to changes. Yes or no? So this is happening when the delta Z is going to be more than delta ZC. Or second one, the minimum rise, yeah, rough channel bed required to cause choked condition is also delta ZC. So whenever the delta Z becomes delta ZC, because delta ZC, from there only the choked condition is going to be happen. Yes or no? So the minimum rise required to cause a choked condition is a delta ZC, because once you go beyond delta ZC, then obviously the choked condition is going to be exist. And the maximum rise without any change in the upstream water level is also delta ZC, because if you go beyond delta ZC, the upstream water level gets disturbed. Okay. So now I hope you understood the figure. Please see, you try to analyze this specific energy curve clearly, because this is very, 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 very important. If you can understand this specific energy curve, then I don't need to explain much things. So you please go through the specific energy curve once, what is happening actually. You observe these figures. So I'm giving you everything in this case. First E1, then channel bed rises by delta Z, specific energy decrease from E1 to E2, flow depth decrease from Y1 to Y2. So please listen to me once again. I'm giving a final review over here. So whenever the channel bed rises by delta Z, specific energy decrease from E1 to E2. When specific energy decrease from E1 to E2, flow depth decrease from Y1 to Y2. Okay. Now, if channel bed rises further as delta Z becomes delta ZC, then specific energy E2 becomes EC. Then Y2 becomes YC. So no change in upstream, but Y2 is going to be YC. So critical flow occurs at delta Z is equals to delta ZC. Critical flow occurs at delta Z is equals to delta ZC. Now, if you rise the delta Z more than delta ZC, then E2 cannot be less than E minimum. E2 cannot be less than E minimum. So the point should not be here. The point should not be here, because the curve is not going to be exist. So in order to occur the flow, now E1 is going to be shifted to E1 dash. When E1 shifts to E1 dash, in the case of the subcritical flow, the upstream depth is going to be increases from Y1 to Y1 dash, and downstream is going to be same, YC. So if you have any doubt, you please have a look now. Sir, but how is total energy line changing? Very good question, my dear. So here the total energy line is changing. See, now I want to say one more point over here. Yeah, listen. Whenever you rise the channel bed more than delta ZC, what happens is the upstream flow thinks the channel bed rise as an obstruction. The upstream flow, whatever the upstream flow, right? The upstream flow thinks the channel bed as an obstruction. So when you rise a channel bed, this upstream flow will think the channel bed rise as an obstruction. And whenever the obstruction comes into the existence, you remember that when the obstruction is going to be comes into the existence, what happens? What happens? The potential energy is going to be increases, kinetic energy is going to be decreases. So that the total energy line is going to be shifts. So that the total energy line is going to be shift. So this is going to be changes due to the changes in the potential energy and kinetic energy media. If you can send this much amount of energy, means E1 dash, see the other words is for a specific energy of E1, the flow can take place up to delta ZC only. And if you want to allow the flow over a transition of delta Z greater than delta ZC, what happens is you require a specific energy of E1 dash. Now, let me show that. So how come we increase in the practical situation? Now I'll tell you the practical situation. Wait for that. A lot of people are asking, sir, why the specific energy is going to be changes, sir. Wait for that moment. What I'm going to say that is. Okay. Yes, it is all about for the subcritical approach only. Now I'm not discussing about supercritical flow. I'm discussing about the subcritical flow only. So now let me show you practically. Please have a look how it is going to be looks for the approaching flow, subcritical, and channel bed is going to be rises. So this is a channel bed. Stop your things and now listen once, please. Okay, so this is, let me take somewhere over here. Here it is going to be delta ZC, and let me take this one is going to be delta Z greater than delta ZC. And if you require further rise, then I'll do that also. And from here onwards, it is going to be constant. So these are horizontal. Okay. So now delta Z is greater than delta ZC. Now I have raised the channel bed beyond delta ZC by this much amount. So this much amount of rise is going to be happen beyond delta ZC. Okay. So now keep that in your mind. I have raised the channel bed over here. So this is a smooth transition. What is happening? So let's come to the water level. Let's come to the water level. So as it is a subcritical flow means larger depth. Okay. Subcritical flow is going to be larger depth. So initially the depth of flow is going to be Y1. Initially the depth of flow is going to be Y1. Okay. So now listen to me carefully. Up to this point, clearly from here to here, is there any channel bottom rise? Is there any channel bottom rise? No. So up to this point, the flow is going to be same. Up to this point, the flow is going to be same. So no change in the water level. So at this point also, the Y2, whatever I have written, I can say Y2 is equals to Y1. Now, from here onwards, the channel bed is going to be rises by delta Z. Okay. When the channel bed is going to be rises by delta Z. Now, you know that when the channel bed is going to be rises by delta Z, what is happening in the case of the subcritical flow? Just go back. Yeah. What is happening when the channel bed rises by delta Z? Then the water level will fall from Y1 to Y2. So the Y2 is going to be false or not? Y1 to Y2. So Y2 is going to be less than Y1. Okay. So now the water level starts to fall from here. Water level starts to fall from here. Okay, my dear. So now, whatever this is a Y2 which is less than Y1. That is a Y2 which is less than Y1. I hope you understood this one. So the water level depth is going to be decreases. I will erase this one. Now it will decrease and decrease and decrease. So if you rise the channel bed further and further, what is going to be happen is, if you rise the channel bed further and further, what is going to be happen over here is, so the channel bed, whenever you rise it to delta Z, then Y2 becomes a YC. Then Y2 becomes YC. So now up to delta ZC. So up to delta ZC, the water level is going to be false, false, and now by the time it reaches, the delta ZC, at this point, can you please tell me what is the flow depth over here, please? The depth of flow is going to be Y2 is equals to YC. The depth of flow is going to be Y2 is equals to YC. So whatever I am drawing over here, this is the water surface. So the water level is going to be false and reaches to the water level. Y2 is equals to YC. Now you see, from here only everything is going to be changes. Okay. So if I rise the delta Z beyond delta ZC, from here onwards, when I rise the delta Z more than delta ZC, the downstream specific energy becomes AC only, but whatever the depth is going to be same or not, you see now, in the case of the delta Z greater than delta ZC, the downstream water level depth should remain as Y2 is equals to YC. The water level depth should remain as Y2 is equals to YC. So what is the tendency of the water level flow here? What is happening? The tendency of the water level is going to be, it is going to be falling like this. Yes or no? The tendency of the water level is going to be falling like this. But now, when I rise the delta Z beyond delta ZC, up to delta ZC, water level has been fallen down, so that Y2 is going to be YC. Y2 less than Y1 and Y2 becomes YC. Okay, fine. Now, think clearly and say the point is, when you rise the channel bed delta Z more than delta ZC, what is the downstream depth? The downstream depth will remain as a YC. The downstream depth will remain as a YC. So if I say the downstream depth is going to be remain as a YC, now whatever the depth everywhere here the depth should be YC. Here also the depth should be YC. Yes or no? So everywhere the depth should be YC. Now, can you please tell me, this is a case where I am going to say the channel bed is going to be rises more than delta ZC. Whenever the channel bed is going to be rises more than delta ZC, what is happening to Y2? Y2 is going to be still YC. Arey Baba, this magnitude is YC and this magnitude is also going to be YC. Whenever the magnitudes of the depth is going to be same, then this channel bed is going to be rises by how much extra? This is the extra. Yes or no? So that now the water level is going to be false or it is going to be rises. Come on, tell me. Up to this point of delta ZC, water level has been fallen down, and now the downstream water level is going to be rises like this. Rises like this. So somebody or some of the people are asking, sir, why the specific energy is going to be changes now. You see, if you raise the channel bit more than delta Z greater than delta ZC, the tendency of the water level is going to be falling. So what is this dotted line is nothing but tendency. But when you raise the delta Z more than delta ZC, the downstream water level depth is going to be remains critical. The downstream water level depth remains critical. What is the meaning of remains critical? Y2 is equals to YC, and here also Y2 is equals to YC. So that this water level is going to be rises. Is it against the tendency or with respect to the tendency? It is against the flow behavior. And now what happens is this water level falls and suddenly rises. This water level falls and suddenly rises. And due to this sudden rise, it is going to be create a wave movement. Due to this sudden rise, it is going to be create a wave movement, and this wave movement will travel towards the upstream. And this wave is known as a surge. In simple words, when you raise the channel bed more than delta ZC, the flow will not be steady. The flow will become unsteady. So whenever the wave movement is going to be created, this wave movement will travel towards the upstream, and then the upstream water level is going to be changes. Now it is no more the initial water level. Now the depth of the water level on the upstream side is going to be Y1 dash. And on the downstream side, the depth is going to be Y2 is equals to YC. So observe the point clearly. What I'm going to say now again is this surge is nothing but an unsteady flow. So whenever the channel bed rises more than delta ZC, how much you rise? You see, here the depth is going to be YC. Here also the depth is going to be YC. How come you make sure both depths are going to be YC? Yet the delta ZC, the depth is YC. Because you see, when you make sure delta ZC, what is E2? EC. When you make sure delta Z more than delta ZC, what is E2? EC. So that in both the cases, Y2 is going to be YC. And when does the Y2 is going to be YC? When does the Y2 is going to be YC? When the water level shifts like this, then only the Y2 will become YC. So in the case of the natural state in practical, what happens is you're an engineer. Whenever you raise the delta Z more than delta ZC, what happens is up to delta ZC water level falls. And if you raise the channel bed more than delta ZC in this zone, you please observe this zone only. In this zone, what is happening is the water level is going to be instead of falling, the water level will rises. And once the water level is going to be rises, it is going to be against the tendency. As it is going to be against the tendency, now due to the sudden rise of water, this water will create a wave pattern, and this wave pattern will move towards the upstream. So I can write once if delta Z is going to be greater than delta ZC, then flow becomes unsteady. And the surge will travel from downstream to upstream, results in change in water level and a specific energy on upstream side because of the unsteady nature. So a lot of people are asking why the specific energy is going to be changes, sir. Because due to surge, it is going to be unsteady flow. So the upstream specific energy is going to be increased from E1 to E1 dash, my dear. Upstream specific energy increases from E1 to E1 dash. So I hope you understood. If you still don't understand, the reality is going to be practicality. first flow depth decreases, decreases, decreases up to delta ZC. And if you go beyond delta ZC, then the surge is going to be created and it will forms towards the upstream. So when the surge travel towards the upstream flow gets disturbed. So the upstream depth changes, upstream specific energy is also going to be changes. So this is while if the flow is going to be subcritical, then this is going to be the happening one. I hope you understood. In practical, this is going to be happen. So in practical, you are an engineer. Now my question for you is, if you don't want to change, if you don't want to happen any disturbance on the upstream side, what is the maximum channel bottom rise that you are going to do? Think and say. If you don't want any change on the upstream level, what is the maximum rise that you want to do? We see up to delta ZC, there is no change in the upstream. But if you go beyond delta ZC, then the upstream will get disturbed. So whenever the delta Z more than delta ZC, the upstream will get disturbed. Okay. So I hope you understood the, yeah, here surge is nothing but hydraulic jump. Yes, but it is a moving hydraulic jump. The surge is nothing but a moving hydraulic jump, my dear. There is a hydraulic jump, but it is a moving hydraulic jump. That's a moving hydraulic jump. That's not a normal hydraulic jump. That's a moving hydraulic jump. So there is a difference between the moving hydraulic jump and normal hydraulic jump that we'll discuss. That we'll discuss later. So can we use this concept for downstream design of dam? Yes, we have to use this one. Then it is no, so it won't be Baba, it won't be supercritical, my dear. It won't be supercritical. There is no supercritical over here. Now here, what is the flow over here? This is going to be the critical. That's it. Because everywhere the Y2 is going to be what? The Y2, everywhere the Y2 is going to YC. There is no supercritical over here. So there is a difference between the hydraulic jump and moving hydraulic jump. So don't worry about that. That we'll be discussing later. What is the difference between the hydraulic jump and moving hydraulic jump? But as of now, I hope you understood this. And further to make a much more understanding. So what I write over here, the conclusions as okay, when delta Z is equals to 0, delta Z is equals to 0, so then E1 is equals to E2. Delta Z greater than 0 means hump R rise. Then E1 is equals to E2 plus delta Z. When delta Z is equals to delta ZC, E1 is equals to EC plus delta ZC. When delta Z greater than delta ZC, then E1 becomes E1 dash and EC becomes EC and delta Z. So these are the relations between the specific energies with respect to the rise of channel bed. Now I want to give one more data with respect to the tabular form. So I will go to the, see, I am showing you the specific energy. I am showing you the with respect to longitudinal section, and I said the concept with respect to the specific energy curve, and I am giving you the points, and I have given you the practically how the flow is going to be happen. And now I give you with respect to the graphical representation. So have a look regarding to the graphical representation. What I am going to represent is on x-axis delta Z, on y-axis upstream and downstream flows, y1 and y2. So this is for subcritical zone. I am telling you, channel bed is going to be rise, and in the case of the subcritical flow. So now, my dear, I'm going to explain from here onwards. All the things are there. This is delta Z is equals to 0. And somewhere the delta Z is equals to delta ZC. Yes. So I want to show the variations over here. So understand this, these graphs are very, very important because recent years they're asking about these things. So it's very useful because this area is whatever the graph I'm going to say, this is untapped area and it has been not appeared much in the GATE or IES. And if I am an examiner, I am the first one to ask this question because this is an untapped area. So now think carefully. What happens when delta Z is 0? And when the delta Z is 0, then the specific energies are going to be same or not? When the specific energies are going to be same, when delta Z is 0, then the flow is going to be subcritical, right? Subcritical means the flow depth is going to be large. Flow depth is going to be large. So initially, this is the flow depth, okay? So as a flow depth is going to be large, now you can observe at this point, Y1 and Y2 both are same. Y1 and Y2 both are same. When delta Z is equals to 0, you go here. When delta Z is 0, E2 and E1 both are same. Y2 and Y1 both are same. Now, as the delta Z is going to be increases, Y1 remains constant, but Y2 is going to be decreases. Accept or not? And when delta Z is going to be up to delta ZC, when delta Z is going to be up to delta ZC, yes. So now, as a delta Z is going to be increases, up to delta ZC, which is going to be changed? Downstream or upstream? Think and say, downstream or upstream? Downstream. So, up to delta ZC, I am going to take the upstream depth Y1 is going to be constant. I am going to take the downstream depth is going to be, means upstream depth is going to be constant, Y1. Any doubt with that? Up to delta ZC. Now, what about the figure? Up to delta ZC, I have shown you the red line only. Up to delta ZC, I have shown you the red line only. The red line represents the initial depth. Y1 is going to be constant and Y2 is going to be changes. Okay. Now, what happens to Y2? The Y2 is going to be decreases, and the Y2 is going to be decreases, and yet delta Z, see, this is nothing but this is the variation of the water surface depth of Y2. So now at delta Z, see, then what is this Y2? Y2 is equals to YC. And what is Y1? Same. So now, I hope you understood. Yet delta Z is equals to 0. Y1 and Y2 both are same. And at delta Z greater than 0 and less than delta ZC, I told you when delta Z is going to be greater than, so then downstream water level falls as Y1 is going to be Y1 to Y2. So Y2 is less than Y1. So in this figure, I am representing that Y2 is less than Y1. Okay. And now when delta Z is equals to delta ZC, then still Y1 is Y1. But what happens to Y2? When delta Z is equal to delta ZC, Y2 is equals to YC. Okay. Now if I go beyond delta ZC, is there any change in the YC? You see? Is there any change in the Y2? Y2. Everywhere the Y2 is going to be same or not? If you go beyond delta ZC, so beyond delta ZC, now I am going beyond delta ZC, the downstream depth is going to be constant with the Y2 is equals to YC. With the Y2 is equals to YC. But what is happening when you go delta Z more than delta ZC, then what is happening to Y1? Y1 is going to be increases to Y1 dash or not? Y1 is going to be increases to Y1 dash. So now the Y1 is going to be increases to Y1 dash. See, this is nothing but Y1 dash. This graph represents that up to delta ZC, no change in the upstream water level depth Y1. And beyond delta ZC, upstream water level depth increases. And up to delta ZC, the downstream depth is going to be decreases and remains critical. And beyond delta ZC, Y2 is equals to YC. If you still have any doubt, you can see this figure. Up to delta ZC, Y1 constant, Y2 is going to be reduces to YC. delta ZC, y1 constant, y2 reduces to yc. Beyond delta ZC, y2 is going to be constant and y1 increases to y1 dash. y2 constant and y1 increases to y1 dash. So still if you feel this is boring, that's up to you, because I have given you all the ways. Why I take this much amount of time for one transition is, if you can understand this transition, then you can say the remaining transitions clearly. I hope you understood this. So if you have understood, let's have a small break. So this is the final things. You can see this figure if you want. So now I'll give a small break. Don't ask me why the y2 is not linear, sir, because never ever the depths are going to be linear. Do you think water level depth is going to be changes with a constant slope? No, it's not going to be changes like that. Okay. So the graphs are not going to be linear, my dear. So that's about, let's have a small break of 15 minutes and we'll resume our session for the next one. See, what our discussion so far is about subcritical. So what happens in the case of subcritical is going to be exactly opposite, right? So that's we'll see for the break. So as we have been discussed about the subcritical flow, let's come to the supercritical flow. If it is a supercritical flow, I don't give this much amount of the explanation. I just directly go with the specific energy curve. So this is about the subcritical flow. So for all these things, I have given this much information, right? So now, in the case of the supercritical flow, if the approaching flow is going to be supercritical, if the approach flow is supercritical, what is going to be happen? So I hope most of the people are there. Okay, fine. Now, see. If the approach flow is going to be supercritical, then from the specific energy curve, again, let's draw the specific energy curve. E and Y. Now, this time we need to look over the supercritical flow. Again, this is EC, and this is going to be YC. So here it is going to be supercritical flow. So I don't write every point now, as you know what is happening when the channel bed is going to be rises further and further. If the channel bed is going to be rises, at first, if the channel bed is going to be rises by delta Z, if the channel bed is going to be rises by delta Z, you know this is nothing but the total energy line. Point number one, as the channel bed is going to be rises by delta Z, this is a specific energy E1 will reduce us to E2. So now specific energy, somewhere it is going to be E1. So E1, it is going to be reduced to E2. So E2 by how much? By delta Z. So this value is going to be delta Z. Then what happens to the depth of flow? When the specific energy is going to be decreased from E1 to E2, then in the case of the supercritical flow, what is happening to the depth of flow? You see, whatever this depth of flow, this is nothing but Y1. For E1, corresponding depth of flow is going to be Y1. Okay. Now, when you raise the channel bed by E2, as the specific energy decreases, this is a supercritical flow which is inversely proportional. So the depth of the flow is going to be increases from Y1 to Y2. The depth of the flow is going to be increases from Y1 to Y2. Okay. So as a specific energy decreases, depth of flow is going to be increases. Here Y1 is going to be increases to Y2, my dear. Now, if I raise the channel bed as a delta ZC, if I raise the channel bed as a delta ZC, then E2 is going to becomes as a EC. So whatever this is nothing but now E2 is equals to EC when delta Z is equals to delta ZC. So if I take it as delta ZC, then E2 will become EC. When E2 will become EC, then Y2 will become YC. Y2 will become YC. So in the case of the supercritical flow, the depth of the flow is going to be increases. Whereas in the case of the subcritical flow, what is the subcritical flow here? The depth of flow is going to be decreases to YC. So now Once yet delta Z is equals to delta ZC, yet delta Z is equals to delta ZC, the flow becomes critical and Y2 is equals to YC. Now, if you raise the channel bed beyond delta ZC, if you raise the channel bed beyond delta ZC, now I'm going to make this delta Z as greater than delta ZC. You know, E2 cannot be less than EC. So for that, what I'm going to do is I'm going to increase from E1 to E1 dash. So now this is E1 dash. When it is going to be E1 dash, now what is happening to Y1? Does Y1 is going to be increasing or decreasing now? This is Y1. Now whatever the depth corresponding to E1 dash. So whatever, this is nothing but Y1 dash. So here, initially, the depth of flow increases from Y1 to YC, and then the downstream depth remains constant as YC, and upstream depth is going to be decreases to Y1 dash. This is exactly opposite. So whenever you raise the channel bed beyond delta ZC, delta Z is greater than delta ZC, then the total energy line is going to be shifts as a TEL dash because of the unsteady nature. But the downstream flow, this is going to be E2 is equals to EC, and upstream specific energy increases from E1 to E1 dash. The concept is same in both subcritical and supercritical. Once you apply that E1, E2, EC and E1 dash, then you can understand whether the water level depth is going to be increases or decreases. Okay. So now, let me draw that. Again, this is a channel bed. Okay. So whatever this is channel bed rise, let's say this is delta ZC, and here this is delta Z, which is more than delta ZC. So this is excess rise beyond the delta ZC. Now I'm discussing about the supercritical flow, right? You know the meaning of supercritical flow, the flow with larger velocity and lesser depth. So in the case of the supercritical flow, the depth of the flow is less, yes or no? So as the depth of the flow is less now, let me take this is the depth of flow, because earlier I have taken for the subcritical flow, the depth is going to be larger. And in the case of the supercritical flow, I am taking the depth of flow is going to be smaller. So now, initially, this is the depth of flow. Let's take this as a depth of flow as a Y1. And up to this point, the depth of flow is going to be same. Yes. Up to here, the depth of flow is going to be same. Now, you tell me what is going to be happen. You know that when delta Z is equals to delta ZC, when delta Z is equals to delta ZC, then Y2 is equals to YC, yes or no? So now, you know that in the case of the supercritical flow, as the channel bed is going to be rises, the depth of flow is going to be increases. The depth of flow is going to be increases. So at this point, whatever this Y2 is nothing but Y1. But if I rise the channel bed, the depth of flow is going to be increases or not. And now, while it is increasing, then C up to delta ZC, the depth of flow is going to be increases like this. And keep that in your mind, this water surface will not be parallel to the channel bed. This water surface will not be parallel to the channel bed, because as the depth is going to be changes, and this depth is going to be increasing or decreasing? Increasing. So you can see anywhere it is not going to be parallel to the channel bed. So by the time it reaches the delta ZC, whatever the depth of flow here, this is nothing but y2 is equals to yc. Now, the tendency of the water level is going to be rises. Yes or no? The tendency of this water surface is going to be rises. But once you go beyond delta ZC, then y2 will become yc only. Yes or no? Once you go beyond delta ZC, then y2 will become yc only. So now here, this is going to be the yc. And here also the depth of flow is going to be yc only, right? So here also the depth of flow is going to be yc. So now the normal tendency of the water level is going to be completely rising. Yes or no? You see here this is y2 grade, y2 is equals to 1. Yes or no? Yes or no? Here the depth is going to be increases, and this normal tendency should be, here. The normal tendency of the flow is going to be y2 greater than yc. Initially y1 is less than yc, right? Initially y1 is less than yc. Supercritical flow, what is mean by supercritical flow? When the y less than yc. Now at a critical flow y2 is equals to yc. But the nature of the tendency is increasing, right? So that it is going to be y2 greater than yc. When y2 greater than yc, it is going to be subcritical flow or not? Yes. But is it going to be possible? No. Because once the flow gets a critical state, the flow depth remains same. So now the actual behavior of the flow is no more this one, but the actual behavior is going to be false like this. The actual behavior is going to be false like this. See, in this case, the actual behavior is falling. The actual behavior is falling, but the water level is going to be rises, so that the surge wave will move travels towards the upstream, and the upstream water level depth has been increased. But now in the case of the supercritical flow, the tendency is rising, but the water level has been fallen down. So now due to this, again the surge wave will travel towards the upstream, and this time now the water level has been fallen down or rises. You see here the tendency, the dotted line is a tendency falling, but the water level rises. When the water level rises, it rises the upstream water level. Yes or no? But in this question, here the tendency is going to be rising, but actually is falling. So as the water level falls, now this surge wave will travels towards the upstream, and it is going to be result in fall of the water level. So now whatever, this is nothing but y1 dash. That's going to be the y1 dash. So I hope you understood. Once it rises, now the surge will travel towards the downstream. So this is a surge travel towards the downstream and lower down the bed level. So now if I draw again the similar type of variation like this for supercritical flow. So if I draw for supercritical flow, you can see now so in the case of the supercritical flow, delta Z and y1 comma y2, y1 comma y2, and somewhere over here this is delta ZC, this is delta ZC. Okay, so initially as it is a super, see this is subcritical flow, so that's the reason why I took larger depth. But now in the case here, this is a supercritical flow, right? As it is a supercritical flow, initially the depth of flows are going to be less, y1 comma y2. So when delta Z is going to be 0, when the delta Z is going to be 0, when delta Z is 0, E1 and E2 both are same, then y1 and y2 both are same. Okay. Now up to delta ZC, you know there is no change in the y1. Yes or no? Up to delta ZC, no change in the y1. Upstream depth is going to be same. Up to delta ZC, no change in the upstream depth. Okay. But what is happening to the downstream depth? You see here, the downstream depth is going to be increased from Y1 to Y2 and Y2 to YC. So now the downstream depth is going to be increases and reaches to yet delta Z is equals to delta ZC. This is Y2 and this Y2 is equals to YC. And beyond delta ZC, everywhere the Y2 is equals to YC only. So beyond delta ZC, everywhere the Y2 is equals to YC. But what is happening to upstream depth? What is happening to upstream depth? The upstream depth is going to be decreasing from Y1 to Y1 dash. Yes. So beyond delta ZC, then E1 becomes E1 dash. Y1 is going to be reduced to Y1 dash. Y1 is going to be reduced to Y1 dash. So now I hope you understood. I have not given you the points, but you know what is happening from the specific energy curve. If you still don't get this, just you please go back to the notes, and after the class you can go through the videos so that you can understand much more better, because I have taken almost 2 hours for explanation of the one transition itself. I hope you got understood. Why the water level rises over here? Why the water level rises? The tendency is down, but water level rises. So due to rise of water level, upstream water level rises. But if you see here, the tendency is rising. The tendency is rising, but water level falls. Due to fall of water level, this surge will lower down the upstream water level. So I hope you understood this. If you have understood this, so have you? You're fine. Now, sir, in graphs and diagram, does always it would be parabolic variation? Yes. Now, in simple words, now as a layman, how to remember this concept? As a layman, how to remember this concept? So come on, my dear, you please understand what I'm going to say here. Yeah. So what is the video? Now, everybody have a look. So what happens? What is happening exactly in the case of the subcritical flow and supercritical flow? So the point is, I'll remember point number 1 while we're discussing about this transition. Is there any critical condition? Is there any choked condition? Yes. In the case of the channel bottom rise, if I rise the channel bottom, there is a critical condition. Yes or no? Accept or not? Yes. So in channel bottom rise, whether it is a subcritical flow or supercritical flow, on the downstream side, at some point there is a critical state. Okay. Now, based upon that, how I am going to remember this concept? See, what is meant by subcritical flow? Subcritical flow is larger than the critical flow or not? Okay. Now I am starting the flow. The flow depth is nothing but subcritical depth, and you know that subcritical depth is more than the critical depth. Accept or not? Subcritical depth is more than the critical depth. Okay, this is subcritical, my dear. And when you raise a channel bed, somewhere over here, the flow can be critical, right? You know, subcritical depth is more than the critical. Subcritical depth is more than the critical. Yes or no? Now you tell me, when you raise a channel bed, the flow will take place from subcritical to supercritical. Sorry, subcritical to critical. Yes or no? So when I raise the channel bed, I know that on the downstream side, somewhere there is a critical. Somewhere there is a critical. Okay. And if the approaching flow is a subcritical, then the water level will fall from larger depth to critical. Yes or no? So that is the reason why in subcritical flow, water level falls to critical. Water level falls to critical. And beyond critical, what happens? Beyond the critical, what is going to be happening? Then the surge is going to be forms and the upstream water level is going to be rises. I hope you understood now. Repeating again, you know, when there is a channel bottom rise, there is a critical state. Critical state means critical depth on the downstream side. In the upstream side, let me say subcritical flow. I'm starting subcritical, I have to reach critical. Subcritical to critical, then the downstream water level is falling or rising? Falling. Downstream water level is going to be falling. And if it is going to be beyond delta ZC, then due to this surge, upstream water level is going to be rises. Now apply the same thing for the supercritical flow. Now channel bottom rise, somewhere critical, but supercritical flow, depth is less than the critical or more than the critical? Less than the critical. Now this is critical, this is supercritical. I want to reach from supercritical to critical. Then the water level is going to be rising or falling? The water level is going to be rises. When the water level is going to be rises on the downstream side and beyond delta ZC, the upstream water level is going to be drops. If you have any doubt, please go back and have a look. In the case of supercritical, first downstream water level falls and then due to surge, upstream water level rises. And in the case of the supercritical, first downstream water level rises and due to surge, upstream water level falls. Okay. I hope you understood this in a layman way also. A lot of people see why you are misjudging the concepts over here, sir. In subcritical, water level is rising, TL is rising. But here water level is rising, but why TL is not falling, sir? See, TEL, total energy, is not about water level, my dear. Total energy is depth and velocity. Think about that. Depth and velocity. You please observe the graphs carefully. Just don't blindly go to the points. I'm explaining the every point over here. You see, in the supercritical, I'm increasing the specific energy from E1 to E1 dash, right? But what is happening to the depth? Y1 is reducing to Y1 dash. Observe the graph. Just see, when you are asking a question, think right. Think. Now, let's go for some of the questions regarding to this channel transition. Yes, this is one of the question that water flows in a rectangular channel at a depth of 1.2 meters. So now you see water is flowing in a rectangular channel at a depth of 1.2 meters and a velocity of 2.4 meters per second. A local rise in the bed of 0.6 meters will cause. A local rise in the bed of 0.6 meters will cause. So what is going to be happen over here? Now, I am saying the local rise means rise of the bed level. Have I mentioned anything regarding to the width change? No. Whenever I discussed about the channel bottom transition, I keep the width as a constant. So let me draw the figure. This is a channel bed rise. And how much rise we have been done? Delta Z is equals to 0.6 meters. This is the 0.6 meters. So, and you know that this is nothing but the total energy line. Total energy line. And whatever the initial depth of flow I have given you in this, the initial depth of flow is Y1. So what is Y1? 1.20 meters. And what is the velocity? The initial velocity V1. So V1 is going to be 2.4 meters per second. See, once we know the type of flow, once we know the velocity and depth, then can I find out the Froude number? Yes or no? See, once I know the depth of flow, I can find out the Froude number. So because if you want to say whether the water level is going to be rising or falling, it depends upon whether the flow is subcritical or supercritical. Subcritical or supercritical. Okay. So now, in order to say whether the flow is subcritical or supercritical, now I need to find out the Froude number. What is the Froude number? V by root Gy. Because in rectangle, you know, D is nothing but Y, right? So in rectangle, D is equals to Y. So now what is velocity initial? 2.4 by root of 9.81 into 1.2. Do I need to find out the value? No, I don't need to, because you see root 9.81 is more than 3, right? Root 9.81 is more than 3. 2.4 by more than 3, then it is going to be less than 1. So I can say the flow is going to be subcritical. Yes, I can say the flow is going to be subcritical. Now, sir, I got to know this is subcritical and channel bed is going to be rising. When the channel bed rises, if it is going to be subcritical, the water level is going to be fall. So the answer is going to be the surface is going to be fall. The surface to fall. So what is the answer? So the channel bed is going to be rising. As the channel bed rises, water level falls. In the case of subcritical, that's what we understood, right? That's what I have been discussing with you. Yes, sir. So here this means the water level is going to be false. Okay. Is it a correct one? Now, I have explained that. Is it a correct one or not? We don't know. Because do you think whatever the delta Z it is there, do you think always the water level is falling? No. You know that the water level is going to be false up to delta ZC. Up to delta ZC. And beyond delta ZC, the surge is going to be traveling towards the upstream or not? Now let's go to the question once again. So in this question, you see one more option is there. A surge is going to be travel the upstream. A surge is going to be travel the upstream. See, if it is a subcritical flow, first the water level will fall and reaches the critical, subcritical, and it falls to critical. And beyond critical, the surge will travel towards the upstream. Yes or no? So there are two options, my dear. See, most of you students, this is the previous gate question, my dear. Most of you students, what they do is, RSR subcritical and channel bed is going to be rises. And I can say the surface is going to be fall. You keep the answer, you will be out of coverage area. See, if I don't mention the magnitude, now in the same question, if I don't mention the magnitude, a local rise in the bed will cause. If I don't mention the magnitude, then you can directly say the water level will fall. But I have mentioned the magnitude. But do I know, does this delta Z is going to be less than delta ZC? Do we know delta Z is less than delta ZC? No. Do we know delta Z is going to be delta ZC? No. Do we know delta Z is going to be more than delta ZC? No. So you know that as long as you don't know the delta ZC, you cannot predict the behavior. So for that, what I have to know now, step number 2. See, the step number 1 is I have find out the type of flow. And step number 2 is I need to check whether delta Z is less than or equals to delta ZC. Check whether given delta Z is less than or equals to or greater than delta ZC. So for finding that delta ZC, now what I do is at a critical state. So I hope you understood whatever the point I stressed now. You cannot directly say the water level is going to be falling. The water level falls up to delta ZC, and then the surge will travel towards the upstream. So there are two options, but both options are there. So here there is a surface to fall and there is a surge also. So you cannot directly predict that. You have to check whether the delta Z is going to be greater than delta ZC, given is less than delta ZC or equals to delta ZC. So first we find out the delta ZC. How, sir? So at a critical state, then whatever the specific energy at 1, look, if I write this as delta ZC, then this is going to be E2. You know, this is E1 and here it is going to be E2. Whenever I write delta Z as delta ZC, then E becomes EC and delta Z becomes delta ZC. Okay. So now with this concept, what is E1? Y1 plus V1 square by 2G is equals to, what is EC? In the case of the rectangle, the EC is nothing but 3 by 2 YC. I hope you remember this EC concept. EC is equals to 3 by 2 YC plus delta ZC. Look, so in order to find out this delta ZC, I have V1 with me, I have Y1 with me. I need to find out whom? YC. Yes or no? So how to find out YC, sir? YC is equals to, you know that Q square by G whole to the power of 1 by 3. Yes or no? So how to find out Q, sir? Small q. See, whatever the depth, you know that in the case of the rectangle, small q is nothing but V into Y. Yes or no? Small q is nothing but V into Y. Okay. So what is Q over here? V1, Y1. 2.4 into 1.2. What is this value? 2.4 into 1.2. So 2.4 into 1.2, which is going to be 2.88 meters square per second. See, the discharge per unit width is going to be constant here because there is no change in the width. So now I can substitute that value. So what is the 2.88 here? So YC is equals to 2.88 square by 9.81 whole to the power of 1 by 3. So find out this value, please. So square by 9.81 whole to the power of 1 by 3. So the value is going to be 0.945. 0.945 meters. Now you please substitute all these values. So what is Y1 given? The given Y1 is 1.2. So 1.2 plus 2.4 square by 2 into 9.81 from this is equals to 3 by 2 into 0.945 plus delta ZC. So you please find out the delta ZC for me and tell me the delta ZC. You please find out the delta ZC for me. If delta Z is not given for us, then we can go for the option 2. But as delta Z is given, you cannot go for the option 2. So come on, tell me this delta ZC value. Find out the delta ZC value. How to say that delta ZC? I'm not going to solve that. I think it comes as 0.06076. Yes or no? 0.076 meters. But given delta Z is 0.6 meters. It is way more than the delta ZC. So the given delta Z is going to be greater than delta ZC. Whenever the delta Z is going to be more than the delta ZC, surge travels towards upstream and upstream water level rises from Y1 to Y1 dash. So now at the end, what I got to know is whether the delta Z is more than delta ZC or less than delta ZC, so that I can say directly. So the value over here is going to be the surge travel to the upstream. What is the answer? Answer is going to be a surge travel to the upstream. Okay, I hope you understood the way to understand this problem. So if you still have any doubt, you please go through the video once again once it is uploaded and go through the class notes. This is to check. I have used this one and I checked it at the end. Okay, so now let's see the next question. Yes. So see this question, please. This is GATE 2016 set 2 marks question. I'll frame the question. Wait for that. I'll frame that in other way also. So first, let me go with the actual concept. Then I'll frame the questions. Okay. So now a 3-meter wide rectangular channel. So again, whatever the channel is a rectangle. So don't think this is a wide rectangle. That's not a wide rectangle. It's a 3-meter wide, which means the rectangular channel is going to be having a width of 3 meters. So the channel is going to be a rectangle and width of the rectangle is going to be 3 meters. Carries a flow, which means a discharge as a 6 meter cube per second. The depth of flow at a section P is a 0.5 meters. So the depth of flow at a section P is going to be 0.5 meters. A flat topped hump. What is the meaning of a flat topped hump? Means a channel bottom rise. So a flat topped hump is to be placed at the downstream. So you're going to place a flat topped hump. You're going to place a flat topped hump and at the downstream section of the P, at the downstream of the section P, assuming negligible energy loss between the section P and hump. See, what I am going to do is, this is a channel bottom, and now I have provided some hump over here. So whatever, this is nothing but a hump. I'm going to provide the hump over here, means rise by delta Z. Now, assuming negligible energy loss. What is the meaning of negligible energy loss? Negligible energy loss means frictionless, which means total energy line is going to be constant. So whatever I provided over here, this is nothing but the hump. So there is a flat top hump I have provided. Now, G value as a 9.81 they have given. And at a section P, this is a section P, what is the depth of water? The depth of water is going to be Y1 as a 0.5 meters. The maximum height of the hump, which will not change the depth of flow at section P. What is the maximum height of a hump, which will not change the depth of flow, upstream depth of flow? See, the section P is at upstream or not? This is upstream and this is a downstream. Yes or no? So maximum rise to provide without a change in upstream depth is delta Z max is equals to delta ZC. Yes or no? So whenever the delta Z, they are asking the maximum. When delta Z max, then that is going to be delta ZC, right? So now, how to find out this delta ZC, sir? Just now I have mentioned you how to find out delta ZC. If I can write down the relation between the specific energies, now this is E1 and here it is going to be, when delta Z max, then it is going to be EC. In simple words, they are asking the maximum height of the hump to not disturb any water surface, which means delta ZC. So now from the figure, I can write down the specific energies E1 is equals to EC, same again delta ZC. And what is E1? Y1 plus V1 square by 2G is equals to 3 by 2 YC plus delta ZC. See, in the previous question, I have given you depth and velocity, but here I have given you the discharge. So now, can I write the velocity V1 is nothing but discharge by area at 1. So V1 is nothing but discharge 6 by area 3 into what is Y1? 0.5. The Y1 is going to be 0.5. So which is going to be like 4 meter per second V1. And similarly, once I know these two, then what is small q? Small q means 6 by 3, which is going to be 2 meters square per second. So now I can substitute these values. I have velocity, I have initial depth of flow 0.5, I have a q. So now this time I'll write down directly y1 plus v1 square by 2g is equals to 3 by 2 into q square by g whole to the power of 1 by 3 plus delta zc. Y1 as 0.5 plus V1 4 square by 2 into 9.81 is equals to 3 by 2 into what is the Q value? 2 square by 9.81 whole to the power of 1 by 3 plus delta ZC. Please find out the delta ZC. Please find out the delta ZC value. Please find out the delta Z value. What is the delta Z, please? 0.203. It's going to be 0.203, I think so. 0.203. Please tell me, is it 0.203? Even I didn't have a calculator with me, so I can't solve it. Yeah. So 0.203, and in the question, they did not mention like rounded to 2 decimals, right? They did not mention like rounded to 2 decimals. So the answer will be given in terms of range. The range is 0.2 to 0.21, something like this. The range would be there because as I did not ask you round off to 2 decimals. If in this question, if they would ask rounded to 2 decimals, then the answer would be 0.21. Then the answer would be 0.20, sorry, 0.20. I hope you understood these conditions. So today, whatever the discussion I have made is a channel bottom transition, which is going to be channel bottom rise, and the channel bottom drop is there that we'll be discussing tomorrow. It's already 9:50, and so I hope you understood how to solve this question regarding to the channel bottom rise. Sir, how Q is 2, sir? You please see, sir. What is Q, sir? Q is nothing but discharge per unit width. So 6 by 3 is nothing but 2 meters square per second. How you are asking this question, Ray? So in gate RIS, they only ask channel transition in rectangle. Yes, because the channel transitions I have already given you. The channel transition means it is for rectangle only. Okay. So I hope this concept is beautiful to you. I hope you understood. As this concept is boring. No, again, asking for signing. What is this here? So okay, go on. Fine, let it be. So with this, I will conclude this today's session. So I have already given those a quick review also. Now, I hope you people understood this. I'll stop. I'll stop this today, and I'll go with some of the questions from of you, and we'll see the remaining things tomorrow. So those who wants to leave, they can leave. And now the outlining session up to 10:15. So those who wants to speak out, they can speak out. Mr. Naresh, speak out, please. Mr. Naresh, please speak out.
Good morning, sir. Hello. Sir, I actually want to ask that does choke condition actually exist, sir, practically?
Practically exists when you raise the channel a bit beyond delta ZC. See, as in, see, we are an engineers, right? I'll ask you one question.
Okay, sir.
See, when we are engineers, are we going to allow the flow from upstream to downstream, downstream to upstream?
So obviously upstream to downstream.
Yeah, which means we don't want any disturbance towards the upstreams, right?
Yes, sir.
Yeah. So when we don't want anything regarding to disturbance on upstream, we always go the channel bed rise delta Z less than delta Z. Yes or no?
Yes, sir.
But sometimes some of the faulty engineers would be there. But every time the engineers are not going to be genuine, right?
Yes, sir.
If all the engineers are genuine, then there wouldn't be any, right?
Yes, sir.
The people who have a less experience or lack of knowledge, they simply raise the channel bit beyond delta ZC. And if you don't know that, means suppose you have raised the channel bit by delta Z as a 0.5 meter, okay?
Okay, sir.
But you don't know whether it is less than delta ZC or more than delta ZC or equal to delta ZC. You allow the flow.
Yes.
Allow the flow into that channel. If you observe, suddenly once the water level crosses that hump and the water is coming back as a surge movement.
Okay.
What that means?
That means, sir, delta Z is greater than delta ZC.
Yes, that's it. Which means that design is wrong. Okay.
So means, sir, as you told that when there is a choke condition, flow will not occur, sir. That does
on the downstream side. On the downstream side, flow will stop.
Okay. Yes. Okay, I got it, sir.
You got my point?
Yes.
Once it reaches a downstream, the flow is going to be critical, but entire flow will remaining. Whatever the incoming flow will come or not.
Yes. That will go back. Yes. Okay. Thank you, sir.
Okay. Next, Miss Jayavardhani.
Hello, sir.
Jayavardhani.
Good morning.
Good morning.
Sir, in case of subcritical...
Can you speak out loud?
Sir, in case of subcritical, ZC at the critical ZC అదే అక్కడ రైజ్ అవుతుంది కదా ZC రైజ్ అవుతుంది అక్కడ సర్జ్ ఫామ్ అయినప్పుడు అప్ స్ట్రీమ్ లెవెల్ కి వెళ్తుంది కదా సార్ వాటర్ అనేది
yes
ఇన్ ద సేమ్ కండిషన్ సూపర్ క్రిటికల్ లో తీసుకున్నప్పుడు డెల్టా ZC దగ్గర మనకి వాటర్ లెవెల్ అనేది రైజ్ అవుతుంది కదా సార్
ఏంటి
సేమ్ కండిషన్ సూపర్ క్రిటికల్ దగ్గర తీసుకున్నప్పుడు సార్
అవును ఓకే టెల్ మీ
అక్కడ డెల్టా ZC దగ్గర మనకి వాటర్ లెవెల్ అనేది రైజ్ అవుతుంది కదా
yes
అక్కడ సర్జ్ మళ్ళీ బ్యాక్ ఫ్లో అయినప్పుడు అదే మళ్ళీ అప్ స్ట్రీమ్ సైడ్ కి ఫ్లో అయినప్పుడు అక్కడ వాటర్ లెవెల్ ఎందుకు సార్ తగ్గుతుంది
ఒకసారి ఇక్కడ చూడండి, నేను చూపిస్తున్న ఫిగర్ చూడండి ఒకసారి.
Yes, sir.
Yeah. What is happening when the flow is going to be happen? When upstream specific energy increase from E1 to E1 dash only, right?
Yes, sir.
Now you see the supercritical flow here. This curve, right?
Yes, sir.
For E1, it is Y1. Yes.
Yes, sir.
For E1 dash, what is this?
Y1 dash.
Is it decreasing or increasing?
Decreasing.
Then you tell me what is happening on the once the surge is moving towards the upstream. Does the water level decrease from Y1 to Y1 dash or increase from Y1 to Y1 dash?
Decreasing, sir.
That's it. Understood?
That's it, sir. Thank you, sir.
Yeah. Okay. Mr. Suklesh, please speak out.
Hello, sir. Good morning.
Good morning, Suklesh.
Sir, I have a doubt from the previous classes, sir. When we were discussing that general classification. Sir, I have a doubt like when you have said that the hydraulic jump will take place when the supercritical meets the subcritical.
Yes.
Sir, when we assume that there is no water on the downstream side.
Okay.
And when we lift the gates.
Okay.
So then there is no subcritical flow to meet, no, sir?
No. It's not like that. See, when you lift the gate, the water is falling from certain height or not?
Yes.
Okay. Once the water is falling certain height, it loses its potential energy and kinetic energy is more. And immediately on the foot of that spillway or gate, the flow is supercritical. Okay.
Yes, sir.
But once it is coming over there, it is going to give some impact on the floor. Yes or no?
Yes, sir.
If you pour some water on the floor, with that impact, again the water tries to rise or not?
Yes, sir. It will rise.
Yeah. So while it is rising, it reaches the subcritical flow.
Okay, while rising.
Yeah. For example, suppose you are lifting the gate suddenly, completely sudden, you open it completely, okay? So that more amount of water is already releasing on the downstream side.
Okay.
When you release more amount of water, then there is no supercritical flow on the starting.
Okay.
So if there is no supercritical flow, then there is no hydraulic jump.
Sir, when we release
hydraulic jump, listen, the formation of hydraulic jump depends upon how you are opening the gate and how you are allowing.
Okay.
If you allow the flow rate slowly, then there is a then there is the formation of jump. But if you allow it suddenly, quickly, means if you allow more amount of discharge at a instant, okay?
Okay, sir.
Then there is no possibility. There may be possibility, there may not be possibility of hydraulic jump. And that we will get to know much more in detail while we discuss about hydraulic jump. Okay?
Okay, sir. Yeah. Thank you, sir.
Miss Navya? Miss Navya, please speak up.
Yes, sir. Good morning, sir.
Good morning.
Sir, in this particular page, for supercritical flow, you drew the graph for Y2. I mean Y1, Y2. For before ZC, Y1 is constant and Y2 is increasing.
Yes.
So why is the graph this way? Why it is not opposite way? I mean, like Y2 is upward concave.
I understood. You are asking why the graph is not like this, convex.
Yeah.
You see, this is going to be convex now. Suddenly, this is a spike, right? If you draw the graph over here, what is the slope? The slope is maximum or not?
Yes, sir.
But suddenly, you see, from slope maximum to, if I draw this one, what is this slope? Slope is 0.
Yes, sir.
Do you think that the slope suddenly changes from infinity to 0?
Okay, sir. Okay, understood.
The variation is going to be linear variation. Means the variation is in such a way, so it should be constant. Yes or no?
Yes, sir.
While you are drawing the graph in this manner, the slope is going to be constantly decreases. See, if I draw like this now, here the slope is more, less, and when the flow is going to be, when it is going to be horizontal, there is no variation. Understood?
Yes, sir. So it should be uniform.
Yeah.
Okay. Thank you, sir. That's it.
Okay. Now, Mr. Maruti.
Hello, sir.
Yeah, tell me more.
Same page.
Can you please speak out a little bit loud?
Sir, in the same page, can you explain the graph once again?
Which graph you are asking me?
That's sir Y1, Y2, and ZC, sir.
You tell me what is happening when you raise a channel bit in the case of supercritical flow. What happens? You tell me first.
Sir, the depth decreases, sir.
In supercritical flow, does the depth decreases in supercritical flow?
No, sir. First increases, sir.
Yeah, you see this one. I am representing here, no? So at first, y1 is not going to be changes, right? Does y1,
Yes, sir. Yes.
does y1 is changing?
No, sir. Y1 is constant, sir. Up to
Y1 is
ZC.
constant up to whom?
Delta ZC, sir.
Yeah, so you can see the blue line represents y1 is constant up to delta ZC. Yes or no?
Yes, sir. Yes.
But what about y2? Y2 is increasing up to YC or not?
Yes, sir.
So y2 is increasing up to YC. So this dotted point I am representing y2 is equals to YC. Now, beyond delta Z, if you go beyond delta ZC, means delta ZC, then E1 is increasing E1 dash or not?
Yes, sir. Yes, sir.
When E1 increases to E1 dash, then Y1 decreases to Y1 dash. Yes or no?
Yes, sir.
Now, what is the meaning of this one? Y1 is decreasing to Y1 dash.
Hmm.
But what about Y2? Y2 is still YC, right?
Yes, sir. Yes.
Yeah, that's it.
Okay. Thank you.
See, up to delta ZC, upstream remain constant. Beyond delta ZC, downstream remain constant. Okay?
Okay, sir.
Yeah. Okay. So I hope all the people doubts has been cleared. Now, Mr. Pushpender.
Hello, good morning, sir.
Tell me, Pushpender.
Sir, in this channel transition, if the initial flow is critical, then what will happen?
If the initial flow is critical, then there is no flow, my dear. The flow is going to be choked. Such type of condition will never exist because we never allow the water in a critical state. Okay. So practically, the critical state is impossible.
No, sir. Here we have the
That's
after
what
the,
I'm saying now. See, critical flow is the flow where the energy is minimum. Are you going to allow the flow with minimum energy itself?
No, sir. But if after channel transition we have this that Y2 equals to YC, right? We have critical flow.
No,
after the
yeah, very good. That critical flow occurs. Choked condition. You are an engineer, right?
Yes, sir.
And are you going to accept that? Are you going to design in such a way to create a choked condition?
No, sir.
That's it. See, when the critical flow occurs, that's a choked condition. But we are engineers, we have to make sure that whatever the rise we are going to do should not exceeding the delta ZC. Understood?
Yes, sir.
Yeah.
Okay, sir. Thank you, sir.
Any other doubts?
No, sir.
Okay. So with this, we have completed today's session. Today's session also. If there is any doubts, you know how to contact me, mail me. So we'll meet in the next class tomorrow morning, same timings. I hope you are able to understand the classes. I'll upload the class PDF as soon as possible.